Morning, everyone. It's Dan Sandig from ICLR on the line. Thanks very much for joining us this morning. It's just about 10 o'clock here, so we'll get started. We're very happy to have Barbara Robinson with us today talking about several ongoing projects that are related to the issue of inflow infiltration, which you'll learn about today, and basement flooding. Several of the projects are joint projects with ICLR. It looks like we have a pretty good crowd here today. Just a quick introduction to Barbara. Barbara is a consultant who's been in the municipal infrastructure sector for several decades. Apologies, Barbara. Her current clients include Township of Woolwich, Region of York, Region of Peel, City of Windsor, City of London, and several private consultants. And she's really taken this topic of inflow infiltration on as a specialty. And I think you'll learn today why it's such an important topic. Just a reminder of the method for receiving questions. If you could use the Q&A box, which should be at the bottom of your screen, to answer your questions. We'll collect all the questions during the presentation and we'll save them for the end. And I should also let you know, that because this is an ongoing question during our presentations, that we'll record this webinar and we'll be posting it to our YouTube site later on today. So that will be available for anybody who's interested. And with that, I'll pass it to Barbara.
Good morning, everyone. I hope everybody's having a good day. I am really honored to have been asked by ICLR to deliver this webinar. We're working on a lot of interesting things together, and I'm really excited about some of the progress that we are making. I want to thank ICLR for thinking outside the box. You know, we're facing a lot of problems in our society related to flooding and climate change and sewers falling apart and budgets and everything. And I guess we're working on a number of projects, and we're really coming at the problem from a whole bunch of different angles because I think that's what we need to do to actually make some traction. So, with that, I'm speaking mostly to an insurance audience, although I'm aware that there are some of my engineering colleagues on the line. So I'm just going to start with just telling you what inflow and infiltration is. I'm going to use that term a lot. It's basically just clean water that gets into sanitary sewers. And it's either rainwater or groundwater. And in engineering, we divide it up into inflow and infiltration because the mechanisms are different and the speed at which it reaches the sewer is different. But for all intents and purposes, it's the same thing. Now, one of the very important things you're going to hear in this webinar is that inflow and infiltration is occurring equally on public property and private property. And this is a big challenge for our industry because those two things operate under under different regimes. And of course, private property is owned by private citizens, and so we have much less, or until now, we've had much less ability to fix I&I on private property. So, and you'll hear many times during the webinar that I&I directly contributes to flooding because the fuller the pipes are with water, the more likely additional water will cause a flooding event. Certainly, if it's a minor flooding event, it may be prevented by getting some of this clean water out or not allowing it to enter the sewers in the first place. So we are doing a lot. ICLR and I are doing a lot. They're doing a lot more, but there's a lot of research that we're doing here. I'm not going to read these, but these are some of the things we're working on. I'm going to highlight the projects in red because we only have an hour, and I want to kind of focus on things that you might be interested in. And I'll mention the other ones, and certainly you can ask more questions or whatever. But yeah, there's a lot going on, and we're making lots of great progress. So firstly, just to set the stage, no matter whether I'm talking about the public side or the private side, I'm just going to remind you what this looks like. So the public side of a sanitary sewer system is the street and the right-of-way. If you can see on this graphic, it's on the left. And it includes the main sewer that's typically underneath the middle of the roadway, and what we call the lateral or the sewer to property line. And then on the other side of the property line is another sewer lateral. It has a different name in the building code, but let's call it a sewer, and it goes to the house. This graphic is a little bit misleading because the sewer on the private side is actually made of different material than the one on the public side. It's much less, it's much thinner walled. It's not as strong, and it doesn't last as long as the sewers we establish on the public side. So one of the big issues we're running into here is the public side work is undertaken by engineering departments. So engineering departments, if a developer comes and wants to develop he takes a big field and wants to build houses, he buys the land, puts his designs in, gets it approved by the city, and he builds the public side. It is aspirationally tested and accepted by the city engineer, and then that contractor goes away, everything's buried, and when it's time to build houses, which often is immediately after, but sometimes is a year or two later, a different group of folks come out, and those are the builders, and then they start building the houses on the private side. So they typically pour the foundation, and during that process, they connect all the sanitary sewers, and they bury them. And at the property line, they actually have to dig up where the private side lateral was left and connect the private side sewer to the public side sewer. So I'm going to talk a lot about that a lot. Once the subdivision is complete, the public side is owned by the city, but the private side is owned by the residents. So you can imagine that removing I&I requires the cooperation of both sides. And in engineering, as Dan said, I've been doing this for decades, thanks Dan. In engineering, we have mostly focused on the public side and not so much on the private side, but that's changing now because we're recognizing that the private side is a big contributor to clean water and sewer systems. So, first project. I've been working on this we discovered this issue in Woolwich Township like 13 years ago. So in my career, I've been working in I&I my whole career, and we never thought that, we always assumed that brand new subdivisions would be not leaking at all. Like the flows would be very low and they would never be leaking, and we never flow monitored them. But just accidentally in St. Jacobs, and this is public, so I'll use their name, I had a flow monitor downstream of a new subdivision, and after it came online, the flows in that flow monitor doubled, and flows should not, the size of the subdivision did not warrant that much of an increase in flow. So we investigated, and we found a series of deficiencies in the subdivision. The contractor corrected them, and that was fine. But subsequent to that, largely because Woolwich has had serious I&I problems at their wastewater treatment plants for years, so I&I is a real problem for them. They decided to flow monitor all new subdivisions, and after that we flow monitored 3 more, and all 3 of those new subdivisions were also leaking. And they're all leaking for different reasons and in different ways, but they're leaking. And by leaking, I mean there's more clean water getting into them than is reasonable to expect from a new sanitary sewer system. So when I started my company, Norton, 2.5 years ago, the first thing I thought was, you know what, I bet you if this is happening in Woolwich, it's happening across Ontario. So I gathered a group of municipal representatives or whatever to get started, and decided to look across Ontario and see what everybody else was seeing. And I had a couple of early funding partners, and one of whom was ICLR, and I'd like to thank them for their foresight on this, because I think it's fair to say this project has a lot of legs right now, but at the beginning it was just my idea, and I just wanted to see what else was going on in Ontario, so I thank Woolwich for that. Currently it's being funded by York, Peel, London, Windsor, Cambridge, Region of Waterloo, and Orangeville, which is fantastic, and it's an ongoing project. So I'll just give you, I have 30 of these kinds of graphs, I'll just show you one. So the line on the top, the red line, is flow versus time in a sewer system, and flow is typically measured in liters per second. So I think this graph is in liters per second. And the blue on the bottom is rainfall. And just so you know how we measure flow in a sewer is we put a flow monitor directly in the sewer, and it can measure how much flow is going by with time. So as you can see from this graph, this is a brand new sewer system. As soon as it rains, that blue spiky stuff about 2/3 of the way across, there's a huge response in the sewers, which means every time it rains, we get a huge slug of water in our system, And this is capacity that we can't be affording to give away. And it's big storms like that where we see we see the worst flooding, I suppose. So this is just terrible. You can't see so well on the scale of this graph, but there's also significant base flow. If I blew it up, you could see that better. Base flow is the flow that's going in the sewer day and night. And if you think about it in a brand new subdivision, if there's no industry or anything else going on in there, you'd expect to see sewer flows that more or less go down to zero at night because, yeah, people will get up and flush a toilet, but typically they're not doing laundry or running a washing machine. Sometimes people are on shift work, so you see more flow. But, you know, I can tell by looking at the characteristics of the development how much base flow I should be seeing, and this is way too much. And this base flow and that peak, the sewer was just built and it has a 75-year life. Those are going to be getting into the sewer for the next 75 years. And this is something we just can't afford to keep allowing. So the first part of the project that I started with Norton Engineering was to actually just survey across Ontario, have you flow monitored any new subdivisions and what have you found? It's not common to flow monitor new subdivisions because I presume everybody else like me assumed that new subdivisions were not leaking, and we never really looked at them. So I had 31 municipalities send me their data. The data is all blind, so I'm never sharing which municipalities said what or where or anything like that. And 94% of them self-reported that the new subdivision was leaking. So basically, almost all the subdivisions were reported as leaking, and that's as defined by the municipality, and I've done a lot of calculations on what the appropriate number is. But anyway, let's just suffice to say, and if you looked at the graphs, you'd see the kind of thing I see here, and even if you're not an engineer, you can tell that there's something wrong with the flows in that pipe. One municipality has advised that their new subdivision, I'm not sure, are not leaking, but I haven't received the data from them, and so I can't really include it as not leaking unless I have the data. And I suspect they're using a different criteria for leaking than I am. But anyway, so that's fine. There's some doubt about that one. And there's one single subdivision in the whole data set that's not leaking, and that happens to be in Woolwich. And the reason that subdivision is not leaking is because developers working in Woolwich are now well aware that I flow monitor downstream of all the subdivisions, and a number of them have had letters of credit or money held back when we found the sewers leaking, and they know that that's going to happen again. So when I contacted the people involved, they said, yeah, when we started construction, we read the Riot Act, and everybody involved and said, if these sewers are leaking, we're not getting paid and you're not getting paid, so build them correctly. And they did. So it can be done. It just takes a little bit of political will. Woolwich happened to have that political will because of the issues at the wastewater treatment plant. So the next stage of the project, so we established, okay, this is a problem across Ontario. Why is it a problem? What's happening here? It's not like the problems we found were just one thing. You know, lateral is always leaking at property line, or roof leaders are connected, or whatever. There wasn't one problem. We found different problems in every subdivision we looked at. So in 2016, 2017, we did detailed surveys of around 30 municipalities and talked to probably 50 more to figure out, you know, as far as they're concerned, what's causing these this I&I. So I had to look at the public side and the private side separately, although when I surveyed, I had both groups in the same room just so everybody could learn from each other. We found 100 things that are problematic or are contributing to the problem. I ran statistics on 4 or 5 of them, and here's one. So on the public side, we work under Ontario standard specifications called OPSS, and those specifications are used by almost every municipality in Ontario. And those specifications say that the pipe on public side must be leak tested before it's accepted by the city engineer. 69% of municipalities are not leak testing these sewers, and 28% are, which is great. And actually, this is the best result of all the questions I asked. And I'll just remind you, the reason we leak test sewers, leak testing, basically, you have a manhole, a sewer, and then a manhole, and you plug the sewer between the 2 manholes, you fill it up with water, and you measure how much that water drops over a specified period of time. So it's pretty easy to do, but it is time consuming. And that's certainly what I was told by staff, is that it's time consuming, contractors complain, and so it's sort of fallen out of favor and we're not doing it so much anymore. Another issue that's quite common, again, those specifications we work under in the public side call for checking the gasket that's between pipes. So when we lay pipes, whether concrete or PVC, you can imagine if we just shove those two pieces together, there would be leakage there. So there's a gasket, like a rubber ring between the sections, and it's installed at each point in the system, or each joint in the sewer. And when we do CCTV is cameraing inside the sewer, and that's where you're looking at now. That's why the photo quality isn't particularly good. When we do CCTV on existing systems, we see this constantly. And if that gasket wasn't seated properly, which it wasn't, then then that's a leaking joint immediately. It's a leaking joint. So the specifications we work under actually call for each and every gasket to be checked once they lay the pipe. And that's not happening at all. I didn't hear any municipality tell me that they were checking gaskets, or they were having the contractor check gaskets at each joint. And you know, there's a practicality to that, because how they lay pipes is they've got one pipe section laid in the trench, and typically these pipes are heavy, so an excavator or whatever puts chains on another piece of pipe and lowers it into the hole, and there are staff standing, contractors standing down there, and they jimmy the new piece of pipe into the old one. Now, they put the gasket around. I've never seen them not put the gasket on, but it's a pretty delicate operation to get that new piece of pipe on without displacing the gasket. However, this pipe is going to leak in perpetuity. And so, yeah, we found that a lot. Okay, so moving over to the private side. The regime under which they work is slightly different. They work under the Ontario Building Code, and actually the requirements of the Ontario Building Code are regulation as opposed to guideline specification that we work with on the public side. So it's actually more essential that these regulations are followed because it's law. So I found similar results on the private side. So, you know, we're all complicit in these issues. On the private side, they're also supposed to test the sewer from the house to the property line and make sure it's not leaking. And 90% of building departments that I spoke to advised that they were not testing the private side lateral. And again, if we're not testing the private side lateral, then if leakage is happening, we'll never know. Well, we could find out if we camera the lateral, but we typically don't unless there's a problem, and these laterals will leak forever. So another issue on the private side. So a pipe on the private side is typically plastic, the stuff you see here. It's thin-walled, and it's nowhere near as strong as the pipe on the public side. The joints are glued together as opposed to gasketed. And a gasketed joint with that rubber thing I just showed you, there's a little bit of room for play there. Not a lot, but one pipe or the other could move a little bit. A glue joint is a rigid joint, so any movement and those joints can easily snap. Now, the OBC calls for granular compacted bedding for that entire sewer, and it's supposed to be compacted up to the spring line of the sewer, and up and over the sewer. And the reason for that is plastic pipe doesn't have its own strength. Concrete pipe has its own strength, but plastic gets its strength from the soil. It's supported by the soil. So if we don't bed these plastic pipes, then there's all kinds of opportunity for them to move. And in this particular instance, I was on site with these guys, and they glued the lateral together, and the one guy at the one end was trying to connect it to the house, and the other guy at the other end was trying to connect it to the public side lateral. And they were moving it around, and the glue wasn't set yet, so all the joints were kind of twisting. And one of them came apart. Well, it was hanging on by a thread, but there was a big gap there. And the building inspector, bless his heart, these guys don't know all this stuff. He said, "Okay, bury it." And I said, I see that joint is open essentially. And the contractor said, "Oh yeah, okay, honey, we'll fix that." And so they fixed the joint. But if I hadn't been standing there, that would have been buried. And I'm pretty sure this probably happens a lot. And then we have a permanent leak in that lateral. And for the insurance folks, I'm sure you can imagine if there's more water in the lateral, the chances of flooding are going to be higher. And again, this is for life because this is a brand new sewer. And the last thing I'll talk, I think this is the last thing, I've just picked out a few examples. So we need to install, it's required, the engineering specifications require that we install a T at property line. And the reason for that is for the building department to actually inspect the private side lateral, they need a way to plug it at the property line. So they can put in a temporary test T or whatever, and I suppose that will work as well, but we're actually required to put in T. And to my knowledge, most municipalities in Ontario are not putting in T's anymore, even though it's called for in the specifications that they use for these projects. Connection of property line. So I just mentioned that this is a place where we often see inflow and infiltration, and that's because, as I said, we dig it up and then we have to recompact. But when you compact differently on two sides of a connection, there's great opportunity for differential settlement. That leak you see there is in a brand new sewer at property line, and you can tell it's property line because the mainline pipe is green, and then you can see it's black. So the black is the private side lateral. That leak is what we call a gusher, meaning there's some pressure behind it. If it was a seeper, it would sort of roll down the side of the pipe. And based on my experience, that's probably a half a liter a second. And if you remember what I said about 1 liter a second has over 40 years has a present value of $1 million. If you can imagine if these kind of gushers and weepers or whatever are going on all over new subdivisions, that's a heck of a lot of money just in treatment. And I'm not even including the making flooding worse because of having all this additional water in the sewers. The vast majority of municipalities are not requiring the CCTV inspection of laterals. That's what this is. But I think we really need to start doing that. Doing it. A couple of municipalities in Ontario are actually now CCTVing the lateral from the house, which means they can go from the house all the way to the property line and then all the way to the mainline sewer, which is great. So it's great to see a few start that, but I think that needs to become very common in our industry. So we found hundreds of different, well, not hundreds, let me call it 100 different issues that are all contributing to this I&I in new subdivisions. And I've talked a lot about testing and all that because that's pretty cut and dried, but there are a lot of other things going on. The regulatory regime is a problem, and coordination between departments, and pressure from developers to get things built and approved. And I understand that. They're trying to get their houses built so they can get their money back. But if they're doing it at the cost of building good infrastructure, then as a municipality or whatever, we're losing a lot by allowing that. And something else that's very important you may not be aware of is in the engineering industry, largely cities are awarding projects based on price, not qualification. Now, often they have prices 10% or 20%, but that means when consultants bid jobs to work on the public sector, on the public side, I should say, we have to price them as low as possible to win the job, and you get what you pay for. So if a job is priced very low, inspection sometimes, even though it's mandated, sometimes corners are cut or whatever, and this is the problem in the engineering industry. It's being dealt with by others, so I'm not taking that one on, but it is affecting how well the work's getting done. Okay, so next topic, and these are all related, is just to talk about I&I and existing sewer systems. So in case you're not aware, I&I exists in all sewer systems. We expect to see I&I in all sewer systems because, as you can imagine, we'd never be able to build systems that were completely leak-free. Well, we could, but the cost would be prohibitive. So most systems in Ontario have significant I&I in them, and I'm talking about separated systems where just the sanitary sewage is supposed to be going into the sanitary sewer. Combined systems like Toronto and Hamilton, they have a whole different set of problems, but I'm talking really about separated systems at this point. So ICL and Norton came up with the idea of, geez, how much is this costing society in Ontario? How much, what's the big picture cost of all this? Because I think we need to start sharing some of those numbers with decision makers and politicians and whomever, because the costs are enormous here. And if we don't put them all together, it's putting them all together in one province, I think, makes a very compelling story. So when we started this, it looked like it was going to be easy. I pulled census data and picked 75% of the population in all those municipalities. I just thought I'll find the water and sewer data, I'll add it all up, and then we'll get a broad number of INI. So something I wasn't aware of is that water data across Ontario is required to be published by municipalities, but sewer data is not. So I thought I would just find all the sewer data online, and it's just not available. And that's not right. There's no reason why the public shouldn't be made aware of their sewer data. I know some municipalities present that data during budget time or whatever, but this should be public data. This is really important to us. So actually, that's the most significant finding of this work. So we're still trying to figure out the best way to come up with the number we're talking about, but I'll just show you a couple of examples. So here's two cities, City A and City B, where I obtained the billed water and wastewater influence. If you look at the bottom line, the blue, that's billed water. So that's how much water comes into homes. And if you think about it, all the water that comes into homes should go out the sanitary sewer and show up at the wastewater treatment plant. Save a few things like lawn watering, which complicates things a little bit, but I'm not making watches here. This is a big picture evaluation. And I'm not naming these cities, these are very typical, but both of these cities are spending $15 million a year on treatment of clean water. And clean water is the red line at the top, so it's wastewater influence minus spilled water. So this is bulk INI. Again, that number is never going to be zero, but that's an awful lot of INI to be treating. And a lot of that is in older systems, and that's fine, but some of that is newer systems as well. In fact, I'm seeing more INI often in 20 and 30-year-old systems than I am in really old systems. So this is just a couple of places. If we add that up across Ontario, I think the numbers are staggering. So we will come up with that. We're just finishing the project. Oh, I thought I already said this. Did I say this? Yeah, the present value of a liter a second is $1 million at $1.50 meters cubed, which is a very low estimate because there's more than just treatment involved and a 3% discount rate. So we need to keep remembering that when we're deciding how much money to spend on inspection and legislation. So for the insurance folks, I'm going to state categorically that there's a direct relationship between INI and flooding. The more water there is in the sewer before a flooding event happens, the more flooding we're going to get. That's it. There's no other way to put it. And one of the problems with INI, even in a non-catastrophic event, like not necessarily a Windsor where we had inundation flooding recently, but just routine, there's a big rainfall, call it, and some houses flood. If we had this clean water or a lot of this clean water out of the sewers, those homes wouldn't have flooded. So every drop of water that gets into a sewer system is going to be contributing to flooding. And in engineering, we build models and we do all kinds of technical analyses, but I don't think we could ever actually quantitatively predict the numerically this relationship, but I'm just going to speak categorically that it exists. So here's a really simple diagram, just so you get a visual of what I'm talking about here. I hope this isn't too simple, but I think it's a compelling graphic. So this is a sewer pipe. And if you look at the bottom, we have sewage, which of course I've made brown. And if you look at the top slice, that's clean water. And so if we didn't have that clean water in the sewer, again, we're always going to have a little bit of clean water, no problem. But I mean, the municipalities I showed you had 40% of the flow in the sewer was clean water. So if you imagine taking that clean water out, that leaves a lot of room in that sewer to allow new development, which everybody in the province wants. Like I just said, provide capacity to reduce routine flooding. And then climate change is upon us. I don't think anybody's going to argue that anymore. So if we had 20% more room in our sewers to convey climate change, events associated with climate change, we'd have a lot less flooding. So we have a lot of work to do here. Okay, so the next project we're working on with ICLR, and this is one of the most interesting things we're doing. Unfortunately, I don't have a lot to report yet because we're having a few legal issues with it, but that's okay. We'll get there. So insurers, I know the large insurers have detailed models to predict risk, and the smaller insurers perhaps less detail. Certainly, insurers often look at basically if you flooded before, you're at risk of flooding, which is a pretty decent measure, I would say, but it's not the only measure to look at. But it's, that's the best information they've got. Now, engineering departments in cities know tons about their sanitary sewer systems. Many of them have dynamic models of their sewer system. They can predict flooding. They can run 100-year storms through their models to see where flooding would occur. They've got data from the guys that work in the field. They have tons of data about their sewer system and how it might respond to larger events. Now, these two data sets are, as far as I know, are never compared because the engineering data is inside an engineering department, and I don't think it would ever get out to an insurer. So with ICLR, and this was Paul Kovac's idea actually, and it's really interesting. We're trying to figure out a way to overlap these two data sets in a way that preserves confidentiality to the extent possible, to the mutual benefit of both. So if cities are better able to manage their systems to avoid flooding, like if they think about and plan for where the flooding might occur, that might be helpful to insurers because insurers would be better able to price risk, which is what you guys want to do. And cities will benefit from this because they'll have less flooding, and of course, flooding is dreadful for cities. It's dreadful for the people who get flooded, but I can tell you, city staff don't have much fun with it either because they don't want people to flood, and it's hard on everybody. So, so we're just working on. I've signed some non-disclosure agreements, and I'm just working with some municipalities to get data from them, and I look forward to having a lot more to report on this. The results will be confidential in the sense that I won't be disclosing which insurers and which cities, but I think we may be able to come up with some ways that we could share data a little bit better than we are now. I'm not going to go through this slide in detail. This is just some of the ways that water can get into sanitary sewers. I imagine you guys have seen this slide before, but I just dropped it into the slide deck in case you have questions later on. I can refer to this picture if you want to know. So there are lots and lots of mechanisms, but these are some of the common ones. So again, it's occurring both on public side and private side. So I've been talking about the costs of I&I in sanitary sewers, and I'll just give you an example of a calculation I did for Hamilton in 2014. So first of all, it's illegal now in Ontario to have roof leaders connected to the sanitary system. Roof leaders, so rain falls on the roof, it goes down the downspout, and then typically, ideally, there's an elbow and an extension. You guys probably all have that at your homes, and the rainwater is discharged to the grass or whatever. There are some places where the plots are so small that that's problematic, but generally speaking, that's what we like to see. So this project, we looked at known roof leaders that were connected to the sanitary sewer. And how we can find that out in engineering is we do something called smoke testing, and it doesn't matter what it is. But anyway, we can positively identify when a roof leader is connected to the sanitary sewer system. So we knew about 773 roof leaders that were connected. Most of them were up on the mountain, so they were discharging into a separated sewer system, which means the sanitary just takes sanitary, and there's a storm sewer for storm. But these roof leaders were going into the sanitary sewer system. So, something we don't typically do. So we looked at all the costs of that, of those connected roof leaders. And this particular case, all that flow comes down the mountain and actually connects into the combined sewer system, which is by the harbor and goes to the wastewater treatment plant. So any drop of water getting into the sewer on the mountain is actually discharged, if it ends up in the combined system. And as you know, Hamilton has an awful lot of flooding, and inquiring minds want to know how much flooding maybe we could reduce anyway, if we got some of these ridiculous roof leaders out of the sanitary sewer system. So we looked at all the costs. Well, I didn't even look at all the costs, but the ones I could reasonably quantify. We looked at treatment costs, staff costs, because when there's a flood, the entire city goes into, overdrive trying to solve problems and help people and do whatever they need to do to resolve all the flooding issues. I looked at insurance claims data. I just used bulk data at average across Canada, because this is still a cost to society. So it costs insurers, of course, but it costs everybody who buys insurance as well, because insurance claims are going up, so premiums are going up. I looked at lost opportunity, because there are development freezes in Hamilton like everywhere else, and some of the capacity in the pipes is getting used up by these known roof leaders that shouldn't be there. I looked at compassionate grants, which get paid when there's an emergency, like I think Windsor just got awarded that by, I'm not sure if it's Ontario or Canada. I think it's Ontario. And I didn't even look at upsizing of trunk sewers required in case of too much flow, and uninsured and unrecoverable costs, of course, that residents are faced with. I had no way of quantifying those. But even just using those costs I used low estimate and high estimates, because I had to make some educated guesses, and I just thought, well, I'll try both. So the cost of those roof leaders are between $6,000 and $11,000 per house per year in Hamilton, and I don't suppose it's much different anywhere else, save and except if you don't have flooding. So it would actually cost about $300 per house to disconnect those roof leaders if the city would go around and do it on behalf of the residents, as is happening in other places in Ontario. And the reason we did this calculation is to try and get more money put towards, fixing some of these problems, as opposed to, other things cities are spending money on. There's lots of things they need to spend money on, but these are pretty compelling numbers. And we can't afford to keep allowing, and flooding is getting worse, so these numbers are just going to get worse. And at the risk of repeating myself, things have to change. Okay, next project that we're working on is the I&I and how the Ontario Building Code provisions are actually contributing to I&I. And the National Building Code as well. I'm currently more familiar with the Ontario Building Code, but we'll extend it to the national as well. So the Ontario Building Code, first of all, is an extremely complex document. My goodness, Dan and I took a one-week course on just house plumbing in the spring, and there's appendices and supplementals, and there's about 6 places where you have to look to find all the information you need for one particular thing. So it's not an easy document to understand. But there are lots of places in the building code where some of the provisions are not preventative of I&I. And as I'll speak to later, most building departments aren't familiar with I&I, clean water and sewer systems, because that's not what they work in. Engineering departments work in that. So there may be things happening on the private side that the building code is allowing that is probably not helping our cause as well. I won't go through all this, but I'll just give you a couple of examples. So, and again, it's contradictory in places, but so I just referenced the code numbers, but 7453 refers to the fact that a foundation drain may connect to a sanitary drainage system. Now, in engineering, this is anathema. So that foundation drain is going into the sanitary sewer. We don't allow it. We don't want it. But if there's a contractor, a builder on site that wants to make that connection and the building inspector isn't familiar with that, it's possible that could happen. I would suggest municipalities in Ontario now have bylaws that prevent connection of weakening tiles to the sanitary sewer. But if the building code doesn't support us on that, the building code is legislation as opposed to bylaw, and I think these kinds of things should not be in the building code. And downspouts, the last one here, just another example, where downspouts are not connected to a sewer. It says a sewer, which by definition, the building code can be sandy or storm. So it's suggesting that it could be connected to a sandy sewer. Again, I don't think any municipalities allow this, but the building code shouldn't be making these kinds of statements when they're totally unacceptable in Ontario right now. Okay, so next item that ICLR and I are both working on is you probably aren't aware of this yet, but CSA has decided to develop a new guideline for basement flood protection. And insurers will be very happy to hear this, because this is going to lay out all the requirements to make sure, or not to make sure basement flooding doesn't happen. We'll never be able to, I can't say that as an engineer, but to mitigate or minimize basement flooding. So that just started this year. It's funded by NRC, and it's a climate change adaptation initiative. So we're looking at the mandatory implementation of protective plumbing equipment, by which we mean things like backflow preventer valves, backups on sump pumps, lot drainage, all that kind of thing is being looked at in this CSA guideline, which will be a standard. And once it's a standard, then it'll be picked up by the various building codes, hopefully the OBC. So it'll say right in the OBC, thou shalt conform to CSA XXX. And so these things will become law in Ontario. I'd like to thank Dan for developing the seed document. He basically wrote a draft of the entire document himself, and it was a fabulous draft because he knows a lot about this stuff. And then the committee is, of course, going through it line by line, and there's 20 of us, I think, who are working on it, and it will be put on. It will be put out for public consultation in January, I think, or possibly February. So we'll get public comment on that and refine it or whatever. So I happen to be the chair of that committee, and Dan is the vice chair. So we're working closely on that. So this is this for insurers. This is going to be a very helpful thing. And these are just some of the graphics that are in that guideline. And again, Dan came up with these or adapted them from other ICLR documents. Again, I'm not going to go through these in detail, but they just show the various mechanisms by which flooding can occur in homes. So you're welcome to look at that in more detail later if you have questions. Dan or I could certainly help you. And major household flood causes, as you know, are sump pump failure or sump pump failure, power failure, failure of building sewers, meaning the lateral on the private side can collapse, etc. There are lots of ways. Back-graded lot grading as well, where the lot is graded towards the house, water flows towards the house, and then it has an opportunity to get into the lateral or the foundation drain, or indeed into the house through cracks or window wells. So just a couple of, again, I won't read these, but these are just out of one chapter. I just grabbed a few things that we're looking at, and one of the things we're looking at is maintenance of the lateral on the private side, which is a big concern because, as you probably know, cities are well, not constantly, but they regularly inspect their sewers. They CCTV them. Typically, once every 5 years, they re-CCTV. Nobody ever looks at laterals. Like the owner owns that lateral, and I would dare say that until and unless they have a problem with their lateral, they never inspect it until they have a backup, and then they look at their lateral and find out it's in rough shape. And I already mentioned that laterals have a much shorter service life than sanitary sewers. I would guess that to be about 30 years. So we really need to start messaging that the lateral is something you own and you need to maintain, like your roof or your furnace. So I think this kind of thing is going to be very valuable in the CSA guidelines. And then I think the last thing I'm going to mention is ICLR is working with the Region of Durham to develop a climate change resistance document. Sorry, I'm not sure the exact name of it. A standard, I guess, which includes circled in green there some of the things that I've been talking about. Urban flooding for sure. So they're also writing up a guideline for a standard for how new buildings should be constructed. So I wouldn't be surprised to see this kind of thing also be developed in lots of municipalities across Ontario. Because again, we need to start doing something, and we need to start doing a lot of things, and we need to start doing them fast. So in conclusion, infiltration and inflow and infiltration is clean water getting into sanitary sewers. Not going away. It directly contributes to flooding. It occurs both on the public and private side of the sewer. And municipalities, insurers, and the public will all benefit from removing or preventing, which actually is cheaper and easier, the cyanide. So ICLR, like I said, they're coming at it from a whole bunch of different directions, because I think that's what we need to do. We need to start being creative. I've been a civil engineer for 27 years, and honestly, the way we lay pipe has never changed. We're doing it the same way. It's probably the same way the Romans did. And that's great, but we need to get more creative, and so we get better results. Well, thank you so much. That's a sewer in Passau. All roads lead to the sanitary sewer in my mind.
Great, thanks very much, Barbara. Sorry, what's this picture we're looking at again?
It's in Passau, Germany.
Ah.
Germany? No, Passau. Anyway, yeah, Passau, Germany. That's right. Yeah.
Okay. Yeah, thanks again. Very interesting, informative presentation. We have lots of questions here from our online participants that I'll start going through now. So first question actually from Paul Kovacs, and I'm not sure, I didn't see mention of the design standard in your presentation, but we've heard it several times from you. But how much ionized is acceptable in a new system, and how much would be considered acceptable over the life of a system?
Okay, great question. I do have lots of slides on that, but it's a little bit complicated. What I can tell you is there's two places in the engineering documents, guidelines, standards where allowable INI is identified. One is in the leak testing of sanitary sewers that's done when the public system is established, and that is 0.01 liters per second per hectare. That probably doesn't mean anything to you. The acceptance testing number, or the long-term allowable INI number is 0.1, so 10 times, 10 times the leak testing, 0.1 to 0.28 liters per second per hectare. So at leak testing, we should be allowing between 4 and 10% of the allowable long-term INI. And it's my position that when a new subdivision is built and we're testing it, we should be looking for it to be closer to the leak. Well, it's supposed to be by legislation, the allowable leak testing at acceptance of the sewer. But functionally, what municipalities are doing is they're using that long-term peak INI number because that's what we put into sanitary sewer design sheet. Sorry, that's a little bit complicated, but so there are numbers out there. Honestly, the 0.28 liters per second per hectare, which is used by many municipalities across Ontario, I don't think it was ever based on any science, but that is the number we have, so municipalities are using that. So there is a big difference between those two numbers, and we need to understand what each of them means and when they're appropriate to be applied in our engineering work.
Okay, so very, very low numbers. And how would that compare to, say, in your experience, a system that's, say, 30 years old? What was a typical INI rate that you would see in a system that's a few decades old?
So it varies widely, Dan. It'd be pretty hard to pick a number off. And also there's two things. There's peak INI, which is problematic for flooding, and then there's, I said before, kind of base low INI. The 0.28 liters per second per hectare is how much INI we should see in years 75 of the life of the sewer. It's peak long-term INI. So I guess if you wanted to take a linear, linearly divide it, so halfway through the life of that sewer, the allowable INI should be 0.14 liters per second per hectare. But many municipalities are now allowing 0.15, 0.2, or 0.28 at the day one of the life of that sewer, which means there's no room in the sewer for that long-term INI that is going to show up.
Okay, thanks. Next question, again from Paul. So the focus of much of the discussion today was on new subdivisions. Can we learn any lessons from for this work for those concerned about existing systems?
Sure, and one of the reasons I focused on new subdivisions is this is something that municipalities can do today. Literally today, they can decide to tidy up some of the processes and procedures that we're working on and fix this now. as opposed to some of our climate change initiatives, which are, 5 or 10 years in the making, I think. So typically municipalities, most municipalities that have I&I have been working on getting it out of their systems for many years, to the extent that, and I'm not sure if I mentioned that, I mentioned that, but in the industry across North America, we have pretty much agreed that 50% of I&I is occurring on private side and 50% on public side, because actually the length of sewer is about equal on each. So many municipalities have already done everything they can on the public side. They've lined their sewers, they've fixed manholes, because they can inspect their own public side, but typically they haven't gotten in the habit of inspecting the private side sewers. There are a few jurisdictions, East Bay Municipal Utility District, which is outside San Francisco, and Metro Vancouver, have moved their I&I reduction programs, their municipal I&I reduction programs, to be exclusively on the private side. So basically, they're spending all their money fixing sewers on the laterals on the private side, because they've done everything they can on the public side, and they still need to keep getting their I&I reduced.
Okay, thanks. Question from Ed about the OBC. So you had several sections there, sentences in your presentation related to installation, pipe bedding, and that sort of thing. How does the OBC govern testing, and what sections specifically are the key sections related to testing of, I suppose, both the lateral and the building drain underneath the floor slab?
Okay, so there are a number of sections that refer to this, including Division 7, which is plumbing, and then there's all kinds of other places where it occurs. I think there are lots of places. I didn't want to list them all because it's a bit complicated, but if perhaps I could, I've got some documents where I've summarized the different things. I'm working on a final report for ICLR where that will all be summarized, and certainly I can, I imagine we'll make that document public or whatever, so we can share that. I think it would be helpful for both public and private side people to understand how the building code might be affecting I&I. So it's mostly in Section 7 plumbing, but it's all through the building code.
Okay, yep. So keep an eye out for a report that'll be coming out hopefully in the next few months.
Yeah.
Another question from Paul: should flow monitoring be mandatory before approval of all new subdivisions? And should these monitors be sustained after the systems are approved?
Absolutely, Paul. That's a great question, and I forgot to say that. So after all the work I've done on I&I in new subdivisions, in my mind, the simplest and most cost-effective way to ensure that this work is done right is to put a flow monitor downstream of every new subdivision. It really isn't the responsibility of the municipality to figure out where this clean water is getting in. That's the developer's responsibility. So if we which is what we did in Woolwich, we put a flow monitor at the downstream end, and if we didn't like the results of the flow monitoring, which we didn't in many cases, we provided that data to the developer and developer's consultant and said, the subdivision is showing unacceptable levels of I&I, please go fix it. And actually, we established the flow monitoring as soon as the trunk system, remember the public site system I was talking about? As soon as that goes in, I want the flow monitoring, because then I can see what's going on in the public system. And then when the builders come along, the nature of the flows change, but it gives me an idea of how much is on the public side and how much is on the private side. And of course, to the extent possible, we should usually share that data with the developer just to give them a heads up or whatever. But it's not up to the municipality to investigate and figure all this out. The developer owns that land until it's accepted by the municipality. Typically, I take the flow monitor out if it's been in for 2 or 3 years and the flows look great. I'm not expecting much to change, so I just pull that flow monitor. And sorry, I didn't mention that ICLR project where we're looking at flow risk, flooding risk and engineering data. One of the main things we're intending to do is establish flow monitoring so we can look at what that looks like as compared to flooding and see if we can't make draw some broad conclusions from that. So we're looking at that with a couple of municipalities right now. We're just waiting for some legal agreements.
Okay, thanks. I think a related question is from one of our online participants. What would be the impact of additional inspection and enforcement on home prices?
I don't think it would have much of an impact. I don't think it would cost either the public sector, public side contractor, nor the private side builder to take a few extra minutes to make sure pipe joints are secured. It's pretty routine stuff. I couldn't imagine it would affect the home price more than 0.5%, if that. Not even that. They're already in the field with all that equipment. If you've ever been on a construction site, there's often a little bit of downtime between bringing a new piece of equipment in or going and grabbing some pipe or whatever. So that time could be used to just ensure that things are done properly. So the inspection services are already paid for by the municipality. Typically, it's the design consultant that does the inspection, and the municipality is paying for full-time inspection. So full-time inspection should be being done, and there's no reason we can't be inspecting all those joints and all that stuff as we go along. The air and water testing takes a little bit longer, but yeah, it would be marginal, if not even noticeable, I would say.
Right, and I think one of your points is that we can save costs down the line by reducing our need to treat all of this water as well.
Correct, and flooding. We can reduce flooding too. So the cost would be peanuts compared to what it's costing us to allow this clean water to get into sewers in the first place.
Right. So actually, a question related to the cost of treating. There was a question from somebody who works in a municipality, and you had your graphs earlier on City A and City B
Yep.
with billed versus treated water.
Yep.
How is the volume of wastewater billed determined when calculating the treatment costs associated with I&I in City A and City B? We bill based on water consumption, therefore it would be difficult to determine an actual volume of wastewater.
So I'm using two different measures. So for billed water, I'm looking at billings from the municipality. And for wastewater influent, I'm looking at the meter at the influent of the wastewater treatment plant. So it's different. I'm not using billed wastewater. I'm using billed water and wastewater at the influent wastewater flow meter at the plant.
Okay. So another question. So again, there's a fair bit of focus on new subdivisions here and I&I rates in new subdivisions. You know, and whether or not that is an indicator or an important factor in considering flood risk. Rob, for example, from a municipality in the GTA is stating we find that even exceeding 0.28 liters per second per hectare by 2 times will not cause flooding in a new subdivision. We've got good examples in said municipality based on recent extreme storms and flow monitoring, and the challenges are in the older systems. Could you provide some comment on the sort of the importance of considering I&I new subdivisions from an urban flood perspective?
Absolutely, and that's a very good question. Generally speaking, I&I new subdivisions is not going to cause flooding in the new subdivision. Firstly, because minimum pipe size in new subdivisions is a 200 millimeter diameter pipe, and the amount of flow coming in the upstream legs in the new subdivision is very low. So I go in those sewers all the time, and it's just a trickle at the bottom of the pipe. So lots of I&I in there wouldn't necessarily cause a problem in the new subdivision. The problem is the flow from the new subdivision flows downstream into the older part of town. Well, not always, it depends on the configuration of your sewer, but it has to flow downstream. You don't have a pipe from the new subdivision straight to the sewage treatment plant typically. So it's contributing to flooding elsewhere in the municipality. So it's not flooding in the new subdivision itself I'm concerned about. I'm concerned about the impact on the rest of the system, which in many municipalities is hanging by a thread, basically, and there are development freezes and stuff. So if we could get some of that new clean water out of there, or not allow it in the first place, we free up room in the pipe for either new development or to mitigate flooding. I think I only answered part of that question, Dan. Is that correct?
Well, I think it addressed the point. And I'm wondering if you might also comment on, say, if there are high rates or higher than expected rates of I&I in new subdivisions, does that say anything about the sort of longevity, the reliability of the system over time? Is a system with lower rates of I&I at the time of construction going to be a better performing system over time?
Absolutely. Another great question. I only had an hour today, so I couldn't cover everything. Yes, a sewer that has I&I. So when I&I is dripping in the side or at a joint, it displaces the support structure around the sewer. So first, the fines will kind of sneak in, and as the fines sneak in, the larger pieces of stone shift. And I told you before that stone around a sewer is supporting the sewer. So as soon as you start getting shifting, it absolutely compromises the design life of the sewer. So I don't have data on that because sewers last 75 years, and I'm not that old yet. But I would say absolutely, because that's how potholes are formed, or sinkholes and potholes are formed by the movement of fines meaning like sand in the ground because of the water, and then the other stronger stuff shifts around, and then there's a depression, and it just gets worse with time. We don't have freeze-thaw issues with sewers, but certainly the movement of those fines is affecting the design life of the sewers.
Okay, thanks. Another question from Rob, a statement. Sometimes groundwater is contaminated and connects to sanitary. Perhaps this is one reason why for the OBC to allow connection in some cases. Markham has a case. Markham has a case of this related to deep conduit foundation drainage high in chlorides. So that could be a reason why we have that flexibility in the OBC. Additional question from Paul. So we were talking about codes and standards, the requirements, and as well as the CSA guideline. Even if we have the best codes and standards, there remains a risk that installations are inadequate. Do municipalities sufficiently invest in enforcement for compliance with codes?
Yeah, another great question, Paul. Actually, right now, we have all the codes and regulations and requirements that we need to adequately install these sewer systems. So it's not typically, I mentioned some inconsistencies in the building code, but I don't think that's the bulk of our problem. We're already calling for all the tests. Well, I mentioned a few of the tests, but there are lots of other tests that are called for and required, but we're not doing them. So we don't, code changes and regulation changes and guideline changes, we're going to be looking at a few of them for other reasons, but the municipalities already have all the power that they need to enforce good construction. And something else, because a lot of people ask me about, are they allowed to flow monitor downstream of a new subdivision? And absolutely. Are they allowed to use that data to tell a developer that they're not willing to accept the subdivision? And absolutely, because all development agreements say something to the effect of the systems, sanitary sewer system, whatever, shall be built to the satisfaction of the city engineer. And when I was city engineer, I had some flow monitors installed at the downstream end of new subdivisions. And if I didn't like the looks of the flows, then I wasn't satisfied, and I sent them back to fix it. Or I didn't get to that point, but I would have. So same as CCTV inspections and all that, the city engineer has to be satisfied that the development was built to specification. And flow monitoring, to me, is the easiest way to figure that out because it doesn't take a lot of effort or cost to the municipality, and it puts the onus on the developer, who, after all, is making the profit on these homes, which is fine. Everybody needs to make a profit, but he's making a profit and then handing over some inadequate infrastructure to the municipalities, and now gets to pay for the next 75 years to look after it more than they really should have to.
Okay, thanks. And a related question from Mark. I would assume this work is dependent upon holding contractors, both public and private, accountable as soon after construction as possible. So maybe you can talk a bit about the experience in Woolwich, where the installation of flow monitors did result in better performing systems. How exactly did that occur? Who sort of changed their behavior to result in better performing systems?
Okay, so again, that's a very easy problem, whatever, if you will. So the developer has a contractual relationship with the township. That's it. Those two have a contractual relationship. The developer hires an engineering consultant to design the infrastructure for him, and he hires builders or has his own builders. So he has a contractual relationship with those two. So all the municipality has to do is he and the developer, I keep saying he, I should say she, but anyway, he and the developer have a contractual relationship, and if the developer does not deliver the product he's looking for, he holds the money up from the developer. Now, the developer, if he's getting his money held up, is going to hold it up from the builders and the contractors and the consulting engineer that are working for him. But the municipality doesn't have to deal with the contractor. He doesn't have a contractual relationship with him. So, and as I said, if contractors know that they're being watched, they just, you know, it's not just the contractors. I'm not trying to single those guys out. There's lots of things going on here. But ultimately, if the contractor is doing a really good job, inspection becomes less important.
Okay, thanks. Additional question from Paul. Your Hamilton example demonstrated the value of disconnecting downspouts. How did Hamilton respond to your findings?
To my knowledge, it wasn't acted upon. And the person I was working for, the project manager I was working for, had since left the city, and he was really kind of the champion behind that work. So, and I didn't mean to single out Hamilton. I just happened to have that data. That is true for every city. The city I live in, I calculated the cost of connected roof leaders at $1,000 per house per year. We're in a separated system. That doesn't sound like much, but roof leaders connected are the easiest and cheapest thing to deal with. And I don't know how many are connected here, neither does the city. But, you know, this is all money that's going into our systems that's costing in many, many different ways. As you all know, I think the City of Toronto now has a mandatory downspout disconnection program. One of the problems with a lot of these things is that bylaw enforcement, who would be the ones to enforce this mandatory disconnection program, are typically, if not exclusively, reactive rather than proactive. So I'm not aware of any bylaw group department going out in a city and actually inspecting things, looking in people's basements to make sure their plumbing is configured correctly, or checking for connected roof leaders. They only respond to, excuse me, a phone call from a resident or whatever. And even in Toronto, although they put this great requirement to disconnect downspouts in place, they didn't increase their bylaw enforcement staff or whatever, so they don't actually have a specific group to enforce that bylaw. So if people don't disconnect unless their neighbors rat on them or somebody's driving around and sees, it's not getting caught. If, you know, municipalities, downspouts should be the first thing you guys all know this. Downspout disconnection is really, it costs you $100. You saw off the downspout and put on an elbow and an extension, and Bob's your uncle. So, but it's hard to enforce, and municipalities are loath to enforce this kind of thing because of the political backlash. Now, Dan and Laura did a study on what power municipalities actually do have over doing things on the private side, and it appears that they have lots of power and indeed are responsible when flooding happens, and it's found that the municipality did not do some of the things that they should have been doing to prevent this flooding. I'm not an expert on that study, but that's municipalities are really loath to upset residents, and I understand that because politicians don't like upset residents, but I don't see how we're going to change this stuff without upsetting residents, unfortunately.
Yeah, well, I think we're getting close in here, so maybe two more questions. But a related question is, so some measures are not politically popular, despite the fact that municipalities have quite a bit of authority to require these measures on the property. There are a number of municipalities, you mentioned Metro Vancouver, but also several in the U.S. that are taking this private side issue more seriously and applying sort of innovative means of addressing private side issues, like the time of sale requirements. Maybe you want to quickly describe what the time of sale requirements are that are being used by some jurisdictions.
Sure. Firstly, in the U.S., it's a slightly different legislative regime because the U.S. EPA essentially sues the municipality if they're not happy, like sues them federally if they're not happy with something the municipality is doing. So in East Bay Mine near San Francisco, they were under a consent decree, which means they're being watched by EPA and are at risk of being sued for the amount of overflows that they were allowing into the bay. So it doesn't look like that here. So the onus to, or the political will to do something is much higher there because they were going to be charged billions of dollars in fees. So the idea of, and I think this is fabulous, and I think we need to look at this in Ontario and across Canada, the idea is implementing a mandatory lateral inspection at real estate transfer. That means if you sell your house, you're required, I think if the lateral is less than 20 years old, or perhaps it's all laterals, I just don't recall. It's probably different in different places. If you're going to sell your house, you are required to get your lateral CCTV, and the municipality has to review and approve that CCTV. And if it's deficient, you're required to fix it and re-camera the lateral before the real estate transaction can go through. And to get your lateral camera, honestly, is a $500 undertaking. It really is peanuts compared to the kinds of problems you're going to run into if you get flooding because of a blocked lateral or a leaking lateral. So, I think this is the way we need to go because, as I mentioned before, municipalities have been working on reducing I&I for years and years and years. And in an old system, you can imagine that downtown city Toronto, they can't dig up all those sewers and put in new ones that aren't leaking or whatever. It's just not economically or socially or politically feasible. So that's why I'm sort of going after some of the new stuff, because like I said, if how we've built stuff hasn't changed over the last, in my career, then the I&I that we're seeing in older systems now, we're going to see in older systems 30 years from now because they're going to be the ones that we're building now that are already leaking. So so that's a great method to ensure laterals are maintained. Again, I suggest they have a design life of about 30 years, so they don't last 100 years and they're going to fall apart.
Right. One of the things that we've discussed here at ICLR is that maybe that's a number insurers might want to keep in mind, or the fact that sewer laterals do have a design life, and it's something to think about with respect to basement flood. So one last question here. There are a number of additional questions online, and I'm not sure, Barbara, if you provided your email address at the end, but I'm sure people can follow up with you if they have more questions.
Yeah.
And I mentioned that we'll be posting this presentation online. So one last question is actually related to the slide that you just moved away from, but again, the $50 million to treat that I&I water, what proportion of the overall treatment cost does that figure represent for those cities?
So I used, in the one city, they have a regional municipality which charges them for sewage treatment. So that was the 275 number. And they pay the same rate for treatment for the first meter cubed and the last meter cubed. So it's not a step down rate with flow. But that's treatment, that's directly what the municipality is paying the upper tier municipality to treat their wastewater. That doesn't include any of the other costs that I've mentioned in the presentation. And let me just add that regarding sewer laterals, I can tell you about my sewer lateral. So my house is 75 years old now, so it would have been 70 years old at the time. And it was blockish a few times, nothing serious. So I had the city come out and they rotted it. And then eventually I had a basement, not really a basement flood because it was just steeping up a little bit or whatever, and I caught it quite quickly. But so when they CCTV'd it, they found every 20 feet where the joints were, it was a net of roots. So every 20 feet, it was totally blocked by roots because roots find their way into the sewer lateral and then block it. So, and I, even though I do this stuff for a living, I had never really thought of replacing my lateral, but so obviously I got my lateral replaced and I'm fine now. But I mean, it's as simple as that. The lateral just doesn't. And also the jointing. I've mentioned the jointing a bunch of times. The jointing is so important because if tree roots can get in, they will.
Okay, thanks again, Barbara. Before we wrap up here, maybe I would invite any last comments?
Actually, I had a comment. Would anybody in the engineering community that's attended, I know who a few of you are, but would you just flip me an email so we know, because we weren't sure how many engineering folks might be on the call. So that would be helpful, because because you didn't log in, we don't have actual names for everybody. So that would help us better plan our next one. Thank you.
Okay, thanks again, Barbara. Great presentation. We'll sure be following up with you again in the future, and probably more presentations. For those of you still online here, thanks for participating, and thanks for all the questions. Our next Friday forum is on October 13th. I don't think it was on the note that was sent out recently, but it will be on October 13th. And we'll have Dr. Steve Quarles from the Insurance Institute for Business and Home Safety talking about wildland urban interface fire risk associated with structures. He's one of the leading scientists in the U.S. working on structure vulnerability to wildland urban interface fire. So that'll be a good talk, and watch your inboxes for that notice. And with that, thanks again for joining, and we'll talk to you again in October.